Hello friends, this video on solid states part 5 is brought to you by examfear.com. No more fear from exam. Now we'll take some numericals on solid state. The first question is, why are solid rigids? So we take examples of solids, for example NaCl or diamond or graphite. If you see the intermolecular force of attraction between the constituent particles, that is ions and atoms or molecules, they are very strong. You see the attraction between these are very strong. Right here, obviously, this is all carbon. This attraction between these carbons are very strong. Here, the graphite, the attraction is very small, very strong. Since the attraction is very strong, these particles actually they can't move. They can't move, right? They can just vibrate in their position, in their mean position. They can't move actually. They can't move from here to here. Since they can't move, and since they have very strong force of attraction, they are rigid, right? Strong force of attraction between the constituent particles, correct? The question is, why solids have definite volume? Same answer. They have very strong force of attraction between the constituent particles. The particles cannot move, but they can just vibrate about their mean positions, and thus they have very strong they have definite shape and they have definite volume, right? They're very rigid also. Please note that all solids have definite shape, but all solids are not rigid. We'll see, we have seen, for example, cake, right? It has different shape but does not rigid. Note that. Here also same thing. Now let's take one numerical way to classify all these solids as amorphous or crystalline. The first is polyethylene. This is polyethylene, right? So we have to classify whether it's amorphous or crystalline. So if you see, it looks very haphazard, right? Even if you cut it, it won't be that smooth. So it will be amorphous. Even if you heat this, what will happen is it will melt like a fluid. That property also shows it's amorphous. Plus, if you cut it, it won't be very sharp. That property also shows it's amorphous. Take example of naphthalene. We have already seen it's crystalline. Naphthalene, it's a crystal. It has a aroma. Right? That is something we know. Structure of naphthalene. Also, if you try to cut, you'll get the sharp edge, right? And I think if you try to melt it, it will have a very sharp melting point. Benzoic acid. Benzoic acid is also crystalline. It's crystalline. Let me put it here only. This is amorphous, this is crystalline. Benzoic acid is also crystalline. This is crystal structure. Teflon. It's very strong, right? So you may think it's a crystalline, it's very strong, but actually it's amorphous. It was discovered in 1938 by Roy Plunkett, yeah. And this Teflon is nothing but polytetrafluoroethylene. Most of the polymers, if you see, are amorphous. This is also amorphous actually. This is Teflon coating is used on this vessels. Right? This is Teflon is amorphous. The next is potassium nitrate. That is crystal. If you see the structure of potassium nitrate is all crystals. It's all irregular pattern. It's all crystalline. Cellophane. Cellophane is used to cover biscuits and all. If you see, there is a very thin paper. Cellophane. That is amorphous actually. Why? The moment you heat it, you will see it melts like a plastic. It is plastic only actually. PVC, again it's similar to plastic, you heat it melts, amorphous. Fiberglass. Fiberglass, if you see in cars, all these bumpers, right? It's generally fiber. Most of the material is fiber only. This rear view mirror, this side is also fiber. Here the flap mudguard is also, if you see, fiber. A lot of things in the car, if you see, is fiber. I mean, most of them are metal also, but you see a lot of fiber things, right? The scooty which girls drive, that is made of mostly fiber. These fibers are very hard plastic. Don't think of plastic only. This fiberglass they call, but they are actually very hard plastic. You see the helmets and all, they are made of fiber. Correct? And they are also amorphous because you can melt it actually. Copper. Copper is actually polycrystalline, but again we told that in this chapter we will assume polycrystalline also as crystalline, so I'll make it as C. That copper is a crystal. If you cut it, you will get the sharp edged copper. So that way you classify the solid states as amorphous and crystalline. Polyurethane is amorphous, naphthalene crystalline, benzoic acid crystalline, Teflon amorphous, potassium crystalline, cellophane amorphous, PVC is again amorphous, fiberglass is amorphous, and copper is crystalline. The question is, why is glass considered super cool liquid? The first is glass is amorphous, we know, right? And this glass has tendency to flow. Correct? And that's why they are called super cool liquid. If you see all this glass we have made, you just melt it first, you get the glass balls, liquid glass, and then you blow and make different shape. Correct? Also, if you see the windows of the old buildings, they are thicker at the bottom. This is the glass window. So if you see this will be thicker at the bottom and thinner at the top. Why? Because the glass flows, right? So that's why glass is called super cool liquid, because they have tendency to flow slowly. Correct? And glass is amorphous, and all amorphous has tendency to flow slowly. The next is refractive index of solid is observed to have same values across all directions. Comment on the nature of the solid. And would show cleavage property. So let's see. So till now we have discussed two types of solids. So this is my crystalline. And this is my amorphous. Now it is saying that the refractive index again is a property, right? The light passes through. You see the refractive index. It is observed to have same values. So if you see here, in this case we told that it will give different values. Here it is passing through 3, here it is passing through more, right? It is giving different values. But here, since everything is haphazard, you go in this direction, you go in this direction, it's almost same. So it is saying that the refractive index is observed to have same values in all directions. That means the kind of compound I am talking about is amorphous. Correct? I am not talking about crystalline. I am talking about amorphous. Now the next question is, would it show cleavage property? Now since this is amorphous, it won't show cleavage property, because if you cut this whatever compound you have got, you cut using knife into two half, right? You won't see the surface to be smooth, so it won't show the cleavage property. It will have an irregular surface. Correct? So the first question was, you need to find whether the substance is amorphous or crystalline, and then just tell if amorphous has cleavage property or not. The next question is, what makes a glass different from solid such as quartz? Under what condition quartz can be converted to glass? So we know that quartz is what? Quartz is my crystalline and glass is amorphous. Correct? Let's first draw the crystalline and amorphous first. So this is my crystalline and this is my amorphous. So first question is, what makes glass different from solid such as glass? This is my glass. Correct? This is my glass, this is amorphous, this is my quartz. So the difference is pretty obvious. We can see the arrangement. So in quartz it is crystalline, it's properly arranged, it's long order arrangement. The glass is not arranged properly, the constituent particles are not arranged properly. Glass is a super cool liquid, it's amorphous. It has short range order, correct? But this quartz has a long range order. Now the question is, how will you convert quartz to glass, that is from crystalline to amorphous? As I told you that nature favors crystallinity because it gives time for all the constituent particles to arrange itself. But if you heat something in a molten state, the liquid state, yes, and you cool it immediately, cool fast, what you get this solid. So now in this case the constituent particles solidifies, but they won't get time to rearrange in the best way. So what you can do is you first heat the quartz. You take the quartz, this totally arranged, or this particle, you heat this first, it becomes haphazard, and then you cool fast immediately, right? You take the quartz, you heat it, you get liquid, you always get the liquid phase. Cool it fast, you get the solid form, but since you cool it very fast, the quartz particles, the constituents, the quartz will not get enough time to rearrange itself in the best possible way. Correct? So it will become amorphous. Hope you understand what happened here. So the same example we took from the old civilization glass, which has crystal nature. Why? Because after a long period of time, and since the glass is a super cool liquid, the glass constituent particles, they arrange themselves in the best possible way, right? They arrange themselves in the crystal manner. But in this case, from crystal to amorphous, you heat something and then cool immediately, it becomes amorphous. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.